A very good day to my panel. I'm Ching from College of Civil Engineering. As you all know, due to the rapid urbanization, the increasing demand for the construction had caused the increase of the usage of cement, which brings lots of environmental problems, such as water pollution and air pollution. But the question is that, how can we possibly to reduce the usage of cement by not bringing any harmful effect to the environment? Today, I'm going to talk to you about how we can do this. In my research, I would like to study the optimum eggshell with 5% TYRE CRUMB as sand replacement on the properties of the high-strength concrete. First of all, I'm going to share with you something about the background of my research, which is the demand of cement currently had been increased as it is the major element of the concrete. My idea is that to replace the cement with the eggshell, which is a waste material which produces about 250,000 tons annually. Besides, I would like to replace the sand in the concrete with the TYRE CRUMB, as lots of the TYRE CRUMB generated in every year. So, this brings me two problem statements. First is the emission of carbon dioxide. The conventional concrete, which uses cement, will contribute about 6% greenhouse gases, especially the carbon dioxide that causes world global warming. The second problem statement is that the disposal of the waste material. From a research done at year 2014, which was done in our country, Malaysia, about 642,000 tons of eggs were produced. 11% of it was the actual waste that produced during that year. Besides, the TYRE CRUMB was also found and discarded without any treatment. These are my objectives of my research. First, I would like to study the workability of high-strength concrete with the eggshell as cement replacement through slump test. Second, I would like to determine the compressive strength of the high-strength concrete with the eggshell as cement replacement. Third, I like to study the quality of high-strength concrete, which using the rebound hammer test and also the ultrasonic pulse velocity test. And fourth, I would like to evaluate the correlation between the compressive strength test and the non-destructive test. My research has been done by using 24 concrete cubes, which consist of 0%, 5%, 10% and 15% eggshell as cement replacement, plus together with the 5% TYRE CRUMB as sand replacement. The testings were conducted through destructive and non-destructive tests for 7 days and 28 days water curing. The research has been done by the casting of high-strength concrete with the addition of superplastic sizer to reduce the water-cement ratio and to increase the strength of the concrete. Therefore, this research can directly relate with the importance of reducing the usage of cement, the emission of carbon dioxide, and waste products such as eggshell and also the TYRE CRUMB. Hence, a sustainable, environmental friendly concrete can be developed. For my literature review, here are some important research that done by the past researchers, which gave me a lot of ideas and useful information credits to my research. Most researches done were conducted by using the normal concrete and only with the replacement of the cement. However, in my research, I like to study for the high-strength concrete and partially replace the cement with the eggshell and TYRE CRUMB for the sand replacement. Have a look on the literature review point number 4. Which was done by Ahmad Hasim Mohammed in 2016 year, where 100 mm cube sample was found to have higher compressive strength than the 150 mm cube specimen. For your information, Table 1 contains the chemical components of the eggshell versus cement. Table 2 contains the chemical components of the TYRE CRUMB versus sand. The calcium oxide in the eggshell were found to have similar amount with the calcium oxide found in the cement, which provides the strength to the cement. The zinc oxide which was found in the TYRE CRUMB well promotes the hydration process to the cement. Next, I would like to move on to the methods that I use in my research. After identifying the problems, I prepare the materials for the casting of the specimens. After the slump test, 24 specimens will undergo water curing. 3 testings were conducted, which are the compressive strength test, rebound hammer test, UPV test on the 7 days and 28 days curing. After that, the results were collected and being analyzed and reported. Here are some of the photos taken in my material preparation. The TYRE CRUMB, eggshell powder, gravel, sand, ordinary Portland cement, and also the super plastic sizer. Take a look at this. Here is the mixed design table, where some variables were set constant, such as the water-cement ratio, aggregate values, TYRE CRUMB, and super plastic sizer. The manipulative variables that had been changed were the cement content and the eggshell powder. Next, move on to the table below. As mentioned in the literature review, 100 mm cube concretes were chosen in my research as it was having higher compressive strength than the 150 mm cube specimen. Next, here are the testings that I had conducted in my research. All of these testings were conducted based on the British standard. The slump test, compressive strength test, rebound hammer test, and the ultrasonic pulse velocity test. This leads me to my next point, the results of my research. For the workability test, 5% of eggshell replacement achieved the highest workability, which is 54 mm with a true slump. However, the workability decreases after reaching the optimum eggshell content. From the past researches done in year 2019, this proves the statement that the increasing of eggshell above the optimum eggshell content will reduce the workability of the concrete. For the compressive strength test, 5% replacement of eggshell achieved the highest result in terms of 7 and 28 days water curing. From the researcher Yu on year 2017, the increasing of compressive strength value was due to the increasing of the EGGSHELL from the 7 days to 28 days water curing. From the researcher Yaramala on the year 2014, he had found out that 5% of the eggshell powder contribute the higher strength than the control concrete. For the rebound hammer test, the data had been tabulated for 7 and 28 days water curing. By using the regression method, R-square value had been obtained for the compressive strength value against the RH rebound hammer value. The graph showed that the actual compressive strength and the predicted compressive strength value. It was clearly shown that the R-square obtained for 7 days was 0.965 and for the 28 days was 0.957. This means that the rebound hammer has a strong correlation with the compressive strength value. The maximum percentage difference was only about 1%, which is just a small difference from the predicted compressive strength. The last test conducted was the UPV test. The results obtained from the UPV was tabulated and all of the velocity obtained, which were more than 3.5 km per second, show that the specimen were rated as good quality specimen. With the same regression method used, R-square value were obtained from the correlation between the compressive strength and the ultrasonic pulse velocity test. The R-square value was lower than 0.8, which means that it was a medium correlation between the compressive strength and the UPV test. The maximum percentage difference was about 3%, which is much more higher than the rebound hammer percentage difference, which is only 1%. To summarize, 5% eggshell as cement replacement achieved the best result in terms of workability test, compressive strength test, rebound hammer test. The UPV value obtained, which is more than 3.5 km per second, show that the specimen were in the good quality of grading. For the comparison of the correlation, rebound hammer show higher correlation with the compressive strength as compared to the UPV test. Therefore, I concluded that 5% eggshell as cement replacement is the optimum eggshell that can be used to partially substitute with the cement. Last but not least, here are some recommendations that can be suggested with the use of the acid and sulfate to test the durability of the concrete. Nano eggshell can be used to obtain higher properties of the concrete. Besides the replacement of eggshell, silica pozzolanic material can also be added to investigate the properties of high-strength concrete. With that, that's all from me. Thank you for your attention and have a nice day.